geometry. Today is the day that we are going to start writing geometric proofs. We're going to be using the theorems, the postulates, the properties, the definitions we've covered so far in a geometric sense. I only have 4 of them. in PO16 Part 2. However, if it's clear that we need more practice, I've got plenty more that we could use. So it's not guaranteed this will be the only day that we cover proofs, but we'll see what happens. So we're going to start with this one here on the top left corner here. Okay, our given statement, what we're told is that angle 1 is congruent to angle 3. Okay, and so when we start our statement reasoning chart here, I'm going to move this up a little bit so we got more space to write. You've got your statement reasoning chart. Okay, our first statement is going to be angle 1 is congruent to angle 3. And why is that? Given. Always begin with the given. Okay? What do I know? Remember, that was one of those questions. What do I know? And our task in this particular proof is to prove that angle 2 is congruent to angle 4. So that should be our last statement. We're given the beginning. We're given where we want to go. Now we've got to fill in the middle. Right? Yes, Ellen. Okay, so now that we've answered the question, what do I know? Now we're moving on to question number 2, which is what can I conclude? Okay, so if Ellen's going to say that angle 1 is congruent to angle 2, she's got to back that up using a definition, a postulate, a theorem, or something. So how are you able to conclude that, Ellen, that angle 1 is congruent to angle 2?
It's one of the properties, like the
vertical angles congruence theorem. Okay, and if you want to just abbreviate that to be vertical angles, that is fine. What's that? The VACT. Since many of you are very unfamiliar with what all these are, I would begin not so much abbreviating. So when you look back on this, you might not remember what VACT stands for. All I'm saying, Joey, is I would recommend not abbreviating too much at this point because you're very unfamiliar with what a lot of these things are still. Okay? And as we go through this, it might be helpful to mark in the diagram kind of what you're concluding as you go to keep track of everything. Okay? We were told that angle 1 is congruent to angle 3. And now we've also been told that angle 1 is, or we've concluded that angle 1 is congruent to angle 2. Alex. Yes, you do need to keep track of what steps are. Is that what you're asking? Yes. Both. He's asking numbering these statements and the reasons. You have to number each of them. Okay? Kylie. Okay. And how can you conclude that angle 3 is congruent to angle 4? Also the vertical angles congruence theorem. Okay? One of the things that the kids who are stuck with proofs is I tell them, look at your proving statements. It involves angles 2 and 4, right? There's nothing about angles 2 and 4 in the given statement, which means we've got to invite these angles to the party, right? We have to introduce them to the proof somehow if our proving statement's going to end up being angle 2 is congruent to angle 4. So one strategy to use here is look at your proving statement and figure out how can I introduce, what do I know about angle 2? What do I know about angle 4? So I can get them to be a part of this. Because if they're not a part of this, they're not going to be a part of your proving statement. Okay? And so what we did was we looked at, what do I know about angle 2? Well, based on its position, Ellen knew it was vertical with angle 1. There we go. We've introduced angle 2. Kylie looked at angle 4 and said, hey, I know that's vertical with angle 3. Look, we've introduced angle 4. And so now we've got to look at what we have, knowing that 1's congruent to 3, 1's also congruent to 2, 3's also congruent to 4, to somehow break that down to be 2 is congruent to 4. Okay? Where do you want to go from here? Arlene?
Maybe angle 3 is congruent to angle 2.
Angle 3 is congruent to angle 2. Why can we say that? We could use transitive. We could also use substitution. But why can you conclude that based on what we already know? And let me write the same down. You said angle 3 is congruent to angle 2. What about what we already know allows us to say that? You don't have to use a fancy reason yet. Just how did you reach that conclusion based on what we have here, Arlene?
Because angle 1 equals angle 3, and it also equals angle 2, then 3 should be the same as
Right. You mentioned the transitive property first, right? We've got A equals B. A also equals C. Therefore, B equals C. Right? We're comparing three things. We know that angle 1 is congruent to two different things. Therefore, they must be congruent to each other. That's what the transitive property is. I also said you could use substitution because if angle 1 is congruent to angle 3, then 3 can be substituted in for angle 1 in any expression or equation. So if we replace angle 1 with angle 3, we've substituted it there. In this case, both properties work. Claire?
We don't have to do that step though, right? Because it's like just a extra step that we don't need. We could just go right to the answer.
Unfortunately, we do have to do this step because there's really four parts we've got going on here. We've got angle 1, angle 3, angle 2, and angle 4. We know that 2 and 4 are each congruent to two angles that are congruent to each other, but there's still kind of four pieces going on here. At minimum, we have to narrow it down to 3. And by writing that angle 3 is congruent to angle 2, now we've got this kind of box here with 3 pieces. Okay, we've removed angle 1 by replacing it with angle 3, and now we've got the same angle, angle 3, being compared to two different angles, 2 and 4. Now we can use a transitive property to make our final conclusion. Because it's too many jumps. Okay, like if I asked you, if you had said in step 4 that angle 2 is congruent to angle 4, and I said why? You said, well, because angle 1 is congruent to 3, which is also congruent to 2, therefore 3 is congruent to 2, and then that's congruent to 4 as well. That's too many steps, right? By doing this intermediate step, step 4, and now step 5, you're saying that angle 2 is congruent to angle 4, and I say, why? Well, you say, well, because 2 and 4 are both congruent to the same angle. The explanation is much more direct than saying, well, 3 is congruent to 1, but 1's also congruent to 2, therefore 3 is congruent to 2, which because 4 is congruent to 3, it means 2 is congruent to 4. That's too many leaps to go from what we had in step 3 directly down to step 5. Proofs are a little bit annoying because they have to be very specific. We can't take too many jumps. Okay, and without step 4, we'd be taking too many jumps. So our reason for step 4, you can either have the transitive or you can have the substitution property. Either one works. And now for step 5, our proving statements. Alan, do you have a question? Or this one is more classic transitive, but it could either one could work here. Because we've essentially substituted angle 4 in for angle 2 and gone that route. But most people would use transitive because it's kind of that classic example of it. But either one would technically be correct. Okay, Anthony.
So they're all basically congruent.
Yes.
So can't you just start with that, end with that?
How? How would you defend that?
It says it proves that they're congruent, and if you put 1 and 2 is congruent, then 3 and 4 has to be congruent.
But you have to state how you know that angle 1 and 2 are congruent, and angle 3 and 4. Math, more specifically the vertical angles congruence theorem. So you'd have to have that. Okay?
So why can't
all gonna be provable?
Yeah, they're all
So
provable.
then why can't you say prove?
Because you have to get there. You have to convince the jury in a court of law, right, your side of the argument. You have to have evidence, you have to have reasoning, you have to have logic, you have to be able to explain your argument from beginning to end in a very logical, specific way. Right? Yeah.
This is math.
Yes. This is logic.
Yes,
This is math is very much math and logic. I mean, those of you that have done coding before, don't you have to be at times overly specific? Those of you that have done advanced coding before, don't you have to be overly specific? Okay. With if this, then that statements. Computer programming is all conditional statements. It's all this logic step-by-step piece. Okay. Think about getting directions from someone. You know, if you're getting directions from someone and their directions are go down this road and take a right, and then a little while later you're gonna come to like this really funky looking tree, take a left there, and then there's a doghouse, you take a right, and then a quick left, and then it's the blue house there. That's kind of hard to follow, right?
I follow that.
Okay.
That's the only I don't know quality directions.
Yes. Yes. You're also the people who will say that you can say this in one step because of math, right? It's more specific.
Exactly.
Beckman.
Wouldn't then angle 1 and 4 be congruent also?
1 and 4 are congruent as well. We're not asked to prove that, but if we were, then we could. Okay. Aiden.
If you use the transitive property, then wouldn't you have to wouldn't it be angle 4 is congruent to angle 2, and then you would have to do
You can write it either way in that case. If we use substitution, then we'd run into the symmetric property, which is why it chose transitive. With the transitive property, you can kind of write it either way there, which is why I went there. Nice pickup on that, though. That was good thinking there. Arlene. Either one. Yep, either one. Okay. Noah. The test will be next week. This is the last objective of the unit, so depending on how long we spend on this, plan on next week. Okay, let's go on to the next one. It is.
You know you can just retake it. Just retake it. You already have 20 retakes.
Okay.
Wait, why are we skipping this test?
Just Anthony, Tipton, Warnings for each of you. Okay. We're going down to the third one. Okay. Because I want to. Okay. Given angle 1 is congruent to angle 3, our job is to prove angle EBA is congruent or is equal to the measure of angle DBC. So take a look at what we have here. Right? Angle 1 and angle 3 are clearly marked. They're marked congruent in the diagram as well. And ultimately, we want to introduce somehow EBA, which is this angle coming from point E down to B and up to A. Right? I'll underline that in green there. And we want to introduce angle DBC, which is from point D down to B and out to C. We want to say that those two angles ultimately have equal measures. Okay? So, we may not use a protractor for this.
It's not skilled with sockets.
Okay? What do we start with? The given. The measure of angle 1 is equal to the measure of angle 3. You need to start with the given because this is what you know. Okay? They're telling you what you are being given. In your proof, you need to state that. This is called your opening argument, your opening statement, right? This is what we know on the night of November 2nd, 2022. My clients, and then so on and so forth, right? You state what you know. Damien, sit flat, please. Okay? Catherine. Okay, well, let's come back to that. Damien, question.
Okay, I have a question.
Yeah.
Yeah, I actually have an answer.
Okay, Catherine, what's the next statement here?
That was my answer. The next
Well, but
statement.
she raised her hand first, so that's why I'm calling on her.
Call on me.
So it's kind of a question too, though, but because it has those like markers showing that they're equal, isn't that like?
So yes, you still need to state it though, right? Basically, if we're going to use angle 1 and angle 3 in any way in the proof, we have to state what we know about them or what we can conclude about them. Because we're told that they're congruent, that's our given statement, we have to state that.
So could this just be like a two-step on there? Because you can just say that and then you can just put that it has the markers.
This can't be a two-step proof unless we know what we can say about EBA and DBC. Angle 1 is only part of, yep. Jack, can you go back over your spot, please? Thank you. Yes. So our next couple steps here should be introducing EBA and EBC. We have to use them in the proof, right? That's our proving statement. So how can we invite them to the party? What do we know about angle EBA? And I will erase both here. I'll just highlight EBA so we can kind of focus on EBA. What do we know about it? Sophie.
So EBA would be is it can we put angle 3 is DBA?
We could identify angle 3 as DBA. How would that help us, do you think?
Because we would end up step 3 then would do C, D, E, and then 2 is E, B, D.
Okay. So the challenge of going over a proof with the whole class is just like, getting from school to your house. There's a lot of different paths that you could take, right? I have to be careful not to let us go down too many different paths. So I'm not going to say that that's an incorrect method to start with, but it's not the most efficient. It's not quite the, it might lead you to some places you haven't been to yet, right? It's a scenic route. So I'm going to nix that this time through, and just let's focus on how can we introduce EBA? What do we know about EBA? Damien.
Angle EBA equals 2 and 3.
Excellent. Excellent. What we know about the measure of angle EBA, okay? The measure of angle EBA is equal to the measure of angle 1 plus the measure of angle 2. The measure of angle EBA is equal to the measure of angle 1 plus the measure of angle 3. Thank you. I'll try and write it neater now, too, then I know how much space I need. Step 2. The measure of angle EBA is equal to the measure of angle 2 plus the measure of angle 3. There we go. Okay, and what allows us to say that? What theorem, postulate, definition, whatever, Kylie? The angle addition postulate, which says that the parts of the angle will sum to equal the whole angle. And the reason why we went that route, how in the world did she pull that out? Or where did he get that from? Again, our goal was to introduce angle EBA because we have to use that in our proving statement anyway. So what did we know about it? We knew that it was the sum of 2 and 3. That's basically it. That's all we can conclude about EBA initially. Okay, Bryn.
Where can I find angle addition postulate?
That was in CO6, I think. Angle addition postulate. 6. Okay. So now let's look at how can we introduce angle DBC. We've introduced EBA. That's part of the proof now. It's at the party. What can we say about angle DBC, which I have there in blue? There are more hands up in the air now because I think you're starting to see some connections. This is good, Jack.
to angle measure 1 and 3.
No, 2.
1 and 2.
You got you, Jack.
Okay.
What's the difference?
I wrote that kind of high. Here, I'm going to erase postulate and put a. There we go. Okay. Step 3 says the measure of angle DBA. I'll write it bigger up here so you can see it. The measure of angle DBA is equal to the measure of angle 2 plus the measure of angle 1. Right? We had to introduce DBA. Take a left at the. There we go. Measure of angle DBC is the measure of angle 2 plus the measure of angle 1. That is what step 3 says. Okay, we've achieved the goal of what we know, and we've achieved the goal of introducing our proving statements. Now our job is to somehow get EBA and DBC together in one equation. Okay, and I'll rewrite steps 2 and 3 up here so it's a little bit clearer. Step 2 is EBA. No, this is EBA. That I'm sure of. Equals measure of angle 2 plus the measure of angle 3, and the measure of angle DBC is equals the measure of angle 2 plus the measure of angle 1.
How did we get 3? Angle 3. I know, but like, what did we do to get? Oh, angle.
And we're given that angle 1 is congruent to angle 3. Okay? So what can we do? Alex. Okay, so Alex is taking angle DBC, which we know is angle 2 plus angle 1, and he's saying because we already know we were given that angle 1 is equal to angle 3, we're going to replace this angle 1 with an angle 3, right? And so our fourth step is going to be the measure of angle DBC equals the measure of angle 2 plus the measure of angle 3. This is step 4. And we can do that because of not given, not transitive. What do? We replaced something with an equivalent value. Substitution. Okay? So step 4 is what we're on right now. Step 4 says the measure of angle DBC is equal to the measure of angle 2 plus the measure of angle 3. Because we replaced that angle 1 with a congruent value, with an equivalent value, angle 3. So this is what your step 4 statement should say here. Okay? Ellen? We could have gone other paths, yes. Okay, it would have gotten you to the same place in the end, right? But like I said, I want to keep us in the same path here. Okay? But now look at what we have here, right? Those that don't have their hands up, maybe you're just being shy or I want to see this connection. Our goal is to prove that EBA is equal to DBC. And in this step now, in our proof, we have an equation that says EBA is 2 plus 3, and we just wrote an equation that says DBC is 2 plus 3. Are we ready to prove that EBA is equal to DBC? Why? Liesel.
Because if measure angle DBC is equal to measure 2 plus 3, then and measure A or A B D, the other angle equals to measure 2 plus 3
3, then they're equal.
Because of the transitive property. We have two different things that are equal to the same thing, okay? Which means that those two different things are themselves equal to each other. If EBA is 2 plus 3 and DBC is 2 plus 3, then EBA has to be equal to DBC. So the measure of angle EBA is equal to the measure of angle DBC, and we get that because of the transitive property. Joey,
How many days are we gonna get to do the test?
I don't know yet. We'll see. Ellen.
So could you not say substitution for the last one? Because you're just replacing, like, since we know, like, measure angle EBA is equal to measure angle.
Yeah, we have to give a reason for what we do, and the reason for that is we substituted an equivalent value in for something else. So yes, you'd have to have that substitution step. You could, but again, it's the classic sign of the transitive property. Also, Aiden brought this point up earlier, Anthony. When using the transitive property, you can kind of put your end result in either order. If we substituted, we might end up in the wrong order and need to use the symmetric property afterward. So it's if given the choice, it's better usually to use the transitive property. Okay, Alex. Substitution is a replacement thing. Transitive property is relating two things to each other. Because we didn't have anything else that was 2 plus 1. You know, like it wasn't 3 congruent things that we were relating to each other. 4 had to be substitution because we replaced part of a statement with something else. Okay, so if we're only replacing a piece of it, we're substituting an equivalent value in for a specific part. The transitive property is taking, 3 relatable things and putting them all together. Okay? Other questions? Comments, concerns, complaints, comments, congratulations, criticisms. Tipton. With which part here? What do you start with? What do you start with?
Given.
Always start with the given. Okay? This is something where you've got to be with it from beginning to end. And the time to raise your hand and say that you're lost isn't when we're all done. Okay? Immediately. We'll do more proofs tomorrow. I'm not going to go back and explain everything here. Okay? But immediately, if you don't get how I got where we, just stop me. Okay? If you don't recognize where you are on the way home from school, you've made a wrong turn, you're someplace you don't recognize, stop. Don't keep driving, right? Don't get more lost. Stop, right? So tomorrow we'll come back to it. Stop me as soon as you realize that you don't know. Ellen. I did say we'd use that. Was that Lauder or Loudest? A Lauder. Okay. We'll use it a lot. Yes. Yes. Yep. Catherine. What was what? Probably transitive. Yeah. Anything else? This is a lot. You folks did very well today as a whole. This is the, I get the sense you're less confused than most groups the first time I go over this, so job well done. Okay, we'll do more tomorrow and we'll see where we end up then. Shh, folks, quiet please. Catherine's got the floor. Max, turn around. Yes, so on CO15 on the test, you'll be doing those algebraic proofs. We have to solve the equation, list the step, doing all of those things. PO16, Anthony, turn around, please. You'll be doing geometric proofs. This kind of stuff here. And what? Yes, any of these are potential proofs. Yeah, you need to know all the postulates, all the theorems, all the stuff. All right, that's IMath, folks. No homework.
Don't forget